Today, our lecture is about Dirac notations, projection operator. Dirac introduces the state vector psi by the symbol which he called a kit. Since a dual space can be associated with every vector space, Dirac denoted the element of a dual space by the symbol which he called a bra vector. Given vector space, V and its dual space is V prime or V star, Dirac associate vectoring vector in V to ket and vectors in V prime to bras. Thus, every kit has a unique bra, that is, a kit vector psi has a unique bra vector. Similarly, A psi plus B psi is equal to A star psi plus B star psi. It also the Scholz inequality which is less than or equal to just like vectors let us consider a line in xy plane this is line L. This is the projection, or this is origin, and this is B. This point C is, as we know that OB is equal to L cos theta and OC is equal to L sin theta. We define it as projection of L along x-axis and the projection L along y-axis. Consider this line as a vector let's say vector space. Then this is vector A, this is OC, this is OB, this is origin. OB is this A1, this is A2. OB is A1 along unit vector I, and OC is A2 along unit vector J. You can also define it as OB is equal to A cos theta and OC is equal to A sin of theta. Vector as A cos theta I plus A sin theta J. In quantum mechanics, replace this A vector by a state vector psi in Hilbert space n dimensional space. Where function psi is the linear combination of psi 1, psi 2, psi 3 up to psi n. With corresponding eigenvalues. A1 up to An. Take the vector psi as A1 psi 1 plus A2 psi 2. Let us our wave function psi has two eigenfunctions, and A1 and A2 are the two eigenvalues. Its complex conjugate psi A1 star bra psi plus A2 star psi 2. Here psi is the state function, wave function, while psi 1 and psi 2 are their corresponding eigenfunction. Where A1, A2 are complex number. They may be constant in special cases or real. The state vector psi is equal to A1 psi 1 plus A2 psi 2. Also obey the definition that I dot I equal to 1, I dot j equal to 0, that is I is equal to when I equal to j and when I is equal to not equal to j. Eigenvectors behaves like a unit vector in Hilbert space. This means this is a state vector psi of t. A1 is the projection of state function psi along psi 1. Similarly, A2 is the projection of state vector psi along psi 2. In quantum mechanics, the observable for this process need to be introduced. This operator represents a binary measurement. Two projection operator is psi2 psi2, and Pn projection operator is as defined by this terms. Let us operate this projection operator on our wave function, that is psi of t is equal to a1 p1 on, sorry, this is psi 1 plus a2 p1 on psi 2. p1 projection operator on state vector psi is a1 p1 psi 1 plus a2 p1 psi 2. P1 projection operator on state vector psi of t is equal to a1. P1 is the projection operator on psi 1 plus a2. P1 is the projection operator on psi 2. So P1 psi of t is equal to a1 psi 1. This term is equal to 1 because the indices are the same, plus a2 psi 1, indices are different, so this is 0. So P1 psi of t is a1 psi 1. Similarly, let us check P2 on psi of t equal to a1 P2 psi 1 plus a2 P2 psi 2 a1. This is projection operator is psi 2 on psi 1 plus a2 projection operator psi 2 the projection operator on psi 2. a1 psi 2 is equal to 0 plus a2 psi 2, and this is equal to 1. a2 psi 2. So projection operator P2 on state vector psi of t is this one. So Pn psi of t is an psi m. psi of t is an psi n. The probability of obtaining one an. The probability of obtaining one of the non-degenerate eigenvalue an of the corresponding operator is psi n psi of t square divided by psi psi. This is the inner product. This is equal to 1. Non-degenerate means eigenvalues correspond to 1 and only one independent eigenstate. This means, for example, eigenvalue a1 corresponding to eigenstate psi 1. Similarly, a2 correspond to eigenstate psi 2. When eigenvalues are M degenerate, this means all M state share the same eigenvalue. These states are orthonormal and independent. For example, a phi n1 is equal to a n phi n1. A operate on phi n2 is equal to a n phi n2. Similarly, a operates on phi nm, which is equal to a n phi nm. So they share the same eigenvalue. Equal to summation j is equal to 1 up to m psi n j psi of t divided by psi n psi. The act of measurement change the state. of a wave function. That is from psi of t to psi n. If the system is already in eigenstate psi n of operator A, then A psi n is equal to A n psi n. We can also show that some properties of the projection operator means to prove that Pi is equal to 1, the projection operator. Operating this on psi of t, where psi of t is defined as psi of t is equal to psi psi of t. This gives us AI, just like psi and psi t is an. Already defined and derived. This means Pi psi of t is psi of t I is equal to 1 up to n, Pi is equal to 1. This is all about the projection operator.